All right, today we're going to get into our last method of solving quadratic equations, which is using the quadratic formula. At this point, we've done square roots, we've done two types of factoring, we've done completing the square, and now we're up to our last method, which is called the quadratic formula. So in this lesson, we're going to get into using what's called the quadratic formula. Just to review our last lesson, I'm going to be doing number 32 from your Unit 8 Regents packet as our do now. So the question says, the method of completing the square was used to solve the equation 2x squared minus 12x plus 6. Which equation is a correct step when using this method? So again, they're telling us that they want us to complete the square, but we don't actually have to solve the whole thing because it just says which is a correct step. So I'm going to start by rewriting my problem. Now, no matter what type of factoring or anything we're doing, it's always helpful to look for a GCF first. And I notice that all of these terms here have a 2, but I can actually go and divide by 2 on both sides just to sort of cancel that out. So we're left with x squared minus 6x plus 3 equals 0. So I kind of simplified this by getting rid of that common factor of 2 amongst all my terms. Now I know that in the completing the square method, what is unique about this method is I don't want this c term on the left side. I want to move that to the other side. So I'll write x squared minus 6x. I'll leave my little space, and I know that 0 minus 3 is negative 3. Now we're up to our next step. That's called the half square share. So we take our b term, which is negative 6. We take half, which is negative 3. And we square that, so squaring negative 3 would give us positive 9, and then we share that number, or we add that number to both sides. Notice on the left side now I have my perfect square trinomial, and I can ask myself what numbers multiply to positive 9 and add to negative 6, and I know that those numbers are x minus 3 and x minus 3. Again, in the completing the square method, you should always have the same binomial twice, which means you can just write it once and square it. So on the left side, we're left with x minus 3 squared. Now on the right side, we just have to simplify. Negative 3 plus 9 should give us positive 6. Now usually I would continue solving, but if you notice in our answer choices, we have just found answer choice 1 as the correct step to solve this method. So again, at this point, you should have done number 32 in your Regents packet for our do now. Now let's get into our lesson, which again today is about the quadratic formula. We're going to be on page 10 in your Solving Quadratic Equations Part 2 packet. So go ahead and pause the video and go find page 10 in your packet. Now before we get into the quadratic formula, I want to just show you where this formula comes from. This is a very well-known formula in really any math class. So we're going to watch this video first to show us where this formula comes from.
In this video, we're going to look at how to derive quadratic formula. To do this, we're going to go back to our rules for completing the square. Well, the first step is we want to get the quadratic equation into the form of x squared plus dx equals g. If you've watched the other videos or seen this in books, you may see that we've used different variables to represent our constants. I did that so we wouldn't confuse the variables in the quadratic equation with the variables we use for the steps of completing the square. The first step is to get the constant in front of the x squared to equal 1. We will do this by dividing all of the terms in the equation by a. And that would leave us 1x squared, or just x squared, plus bx over a plus c over a equals 0. We also need to get the c over a on the other side of the equation, and we'll do that by adding negative ca to both sides of the equation. Now I need to figure out what number I need to add to both sides to complete the square. We're going to take 1/2 of the term in front of x, and we're going to square that. And that would leave us with b over 2a quantity squared. And I'll add that to both sides of the equation. On the right-hand side, I'm going to go ahead and multiply that out because I'd like to combine my two fractions. So I get b squared over 4a squared plus negative c over a. Before I can add those two terms, I have to have a common denominator. So what I'm going to do is to multiply both the numerator and the denominator of negative c over a by 4a. Now I have a common denominator of 4a squared. The next will be to factor the left-hand side, which gives me x plus b over 2a, quantity squared. And on the right-hand side, I'm going to go ahead and complete the addition, and I will end up with b squared over 4ac divided by 4a squared. Next, I'm going to take the square root of both sides. On the left-hand side, I'll get x plus b over 2a is equal to the right-hand side, which is plus or minus the square root of both the top and the bottom of the fraction. The square root of 4a squared is 2a, so that will be my denominator. Next up is to solve for x. So I want to subtract b over 2a from both sides of the equation. That would leave me with negative b over 2a plus or minus the square root b squared minus 4ac divided by 2a. Of course, I can combine those because I have a common denominator, and I get the quadratic equation in its traditional form. X is equal to negative b plus or minus the square root b squared minus 4ac divided by 2a. Not only is it fun to see where the quadratic formula came from, but this way if you forget it, you can recreate it yourself.
So again, this video shows you how we took an equation in standard form. We used the process of completing the square to come up with what's known as the quadratic formula. Now, the good thing is that you will not have to ever derive that again yourself. Now you just know where it comes from, and you just have to work on memorizing the formula. Now, there's a bunch of different ways that you can memorize this crazy formula. This video shows the way that I personally remember it. This is to the tune of Pop Goes the Weasel.
When you need to memorize a quadratic formula, a nice way is to sing it. I find that it fits nicely to Pop Goes the Weasel. X equals negative b plus and minus square root b squared minus 4ac all over 2a. Again, x equals negative b plus and minus square root b squared minus 4ac all over 2a.
So again, that's one way that you can try to memorize the formula, and if you're all kind of sitting there thinking, how am I ever going to remember this? I want to show you that even a small child is able to remember this formula.
X equals
negative b. X equals negative b plus or minus square root b squared minus 4ac all over 2.
So you guys can see that even a little kid can remember this formula. So let's get back into our packet on page 10. It says solving by using the quadratic formula. The quadratic formula can be used to solve any quadratic equation written in standard form. So just to pause right there, this method is unique in that you can solve any quadratic equation. So this method will always work. It says to use the formula, check that the equation is in standard form, which we know that standard form looks like this: ax squared plus bx plus c equals 0. And it says if it's not, rewrite it in standard form, then substitute the values for a, b, and c into the formula. So again, we want to write it in standard form, and then we identify our a, our b, and our c, and we just go ahead and substitute into our quadratic formula. So go ahead and take a moment, pause this video, please read through examples A and B, and try to answer your 2 think right pair share questions. Okay, looking at our first question, it said, what must you check first before you can identify A, B, and C and use the quadratic formula? And this, like I said at the very beginning, you must check that the equation is in standard form. So this, notice, is the same first step as when we were factoring, but it's a different first step than when we were completing the square. So the first thing that you have to do is make sure that your equation is in the form ax squared plus bx plus c equals 0. Then you can identify a, b, and c and plug it into your formula. Question number 2 says, what is different about the solutions for example A and example B? So you'll notice in both problems, they substituted their values in for A, B, and C into the formula, but they got totally different answers. So if you notice when they got to this middle step here of simplifying their work, The big difference here lied in what was inside of the square root or the radical symbol. In example A, you'll notice here that we had the square root of 49, which is a perfect square. So in A, because 49 was a perfect square, that means that we had rational solutions. So if you look at the work for A, after they had the square root of 49, they simplified that to 7. And then to get their two answers, they did -3 plus 7 divided by 4, which is 1, and -3 minus 7 divided by 4, which is -5/2 or -2.5. However, when you look at example B, in B we ended up with the square root of 20. Now 20 is not a perfect square, so that means that we still had that radical inside of our answers. They did a little bit of work to simplify that radical, but for B we're going to say that we have irrational solutions because 20 is not a perfect square. Okay, so the process of substituting A, B, and C and simplifying will be the same, but you see here that your answers will all be a little bit different. Let's go ahead and take a look at the two guided practice problems at the bottom of page 10. If you're feeling ready to start one of the problems by yourself, go ahead and give it a try. So I'm going to start with the first guided practice problem. Again, my first step is always to make sure that my quadratic formula is in standard form, which luckily here it is. So I'm going to start first by identifying my A, my B, and my C. And I like to make a little list off to the side for myself. So I know here that A is 2, B is -8, and C is +1. Notice that you must pay attention to the sign, positive or negative, when you identify your A, B, and C. I'm going to start first by rewriting my formula. X equals -b plus or minus the square root b squared minus 4ac all over 2a. Now let's go ahead and substitute our numbers in. X equals negative. Now b was -8, so notice I have -8 plus or minus the square root b squared. So that's -8 squared. Notice I'm using parentheses. Minus 4ac, so 4 times 2 times 1, all over 2a, or 2 times 2. Now let's just go ahead and simplify. Looking at the beginning here, -8, I know that a negative times a negative is a positive, so I'm just going to write x equals regular +8 plus or minus. Now in this step right here, I want you to be paying attention to the order of operations and simplifying what's on the inside. If you have access to a calculator, which you all should on the internet, you can go ahead and do -8 squared minus 4 times 2 times 1. And you should end up with 56 as the number inside of your radical. All over 2 times 2, which is 4. Now, sometimes we might be able to stop right here, but I always want to examine what number is inside of my square root. So the number that I see here is 56. So I want to first think, is 56 a perfect square? No, it's not. But then I want to ask myself, are any of the factors of 56 perfect squares? So I would go over to the side, I would list off my factors of 56. And what I notice is that one of the factors of 56 is 4 times 14. And I know that 4 is a perfect square. So I'm going to focus on those two factors there. And I'm going to split this radical up into the square root of 4 times the square root of 14. Now I know that the square root of 4 is just 2. So I'm going to rewrite this as x equals 8 plus or minus 2 square root of 14 all over 4. Again, all I did in that step there was I took the square root of 56 and I broke it down into its simplest radical form, which is 2 square root of 14. Now, you could go ahead and leave your answer just like this if you wanted to. This would be totally fine, but sometimes you'll see on the regions that they break it down even further. If I wanted to break this up into two fractions, I would break this up into 8 over 4 plus or minus 2 square root of 14 also over 4. Notice all I did was break up that fraction into 2 different fractions, and I could go ahead and simplify this further. 8 divided by 4 is 2, and I know 2 divided by 4 is a half, so plus or minus 1/2 square root of 14. So this could be another way that you write your answer, but again, you could have just left it as we originally had. At this point, I'd like you to try to pause the video and try to answer the second guided practice problem by yourself. Okay, so looking at the second guided practice problem, I notice that the first issue is that this quadratic equation is not in standard form. So I need to either move all the terms to the left side or all the terms to the right side. I'm going to choose to move everything over to the right side because I want to keep that 3x squared as positive, but I could have also moved everything to the left side. Moving everything over to the right side would give us 0 equals 3x squared minus 5x minus 2. Notice that it's kind of backwards, but it's okay. It's still in standard form. At this point, I would identify my A, my B, and my C. So here I would see that A would be positive 3, B would be negative 5, and C would be positive 2. I'm going to go ahead and plug that into the quadratic formula. So x equals negative b, so that's negative 5, plus or minus square root b squared, so that's negative 5 squared, minus 4ac, so 4 times 3 times 2, all over 2a, so 2 times 3. Going through to simplify this, x equals a negative times a negative is a positive, so that's positive 5, plus or minus. Again, I would go ahead and put all of this mess inside of the square root into your calculator. The number that you should end up getting here is 49, all over 2 times 3, which is 6. Now here, this one's going to be a little different than our first problem because 49 is a perfect square. We know that the square root of 49 is just 7. So we're left with 5 plus or minus 7 divided by 6. Now to get my 2 different answers here, for the first answer, we're going to do 5 plus 7 divided by 6. And for our second answer, we're going to do 5 minus 7 divided by 6. So for our first answer, 5 plus 7 is 12. 12 divided by 6 is 2. For our second answer, 5 minus 7 is negative 2. Negative 2 divided by 6, well, that's just a decimal. But if I want to keep that in simplest fractional form, I would get negative 1/3. So you'll notice that the process for simplifying was the same as the first problem. Again, I just ended up with 2 rational solutions because 49 was a perfect square. If you want to see more examples of how to work out the quadratic formula before you try your checkpoint question, please go back into Google Classroom and take a look at the Khan Academy link that I left for you there. But at this point in the lesson, I would like you to try your checkpoint question. Please pause this video, answer this question as best as you can on a piece of loose leaf paper, and then come back to check your answers. Okay, so the first thing that you should have done for this checkpoint was get your equation into standard form. I'm going to move everything over to the left side. So I'll be left with x squared minus x minus 20 equals 0. Notice that this is in standard form, so I can identify A, B, and C. So you'll notice in this problem, A, there was no number out front, so that's invisible 1. B would be an invisible negative 1 in front of that negative x, and C would be negative 20. Plugging into our formula, we have x equals negative b, so negative 1 plus or minus the square root b squared, so that's negative 1 squared, minus 4ac all over 2a. Simplifying this a little bit, x equals negative 1, that's just positive 1, plus or minus. If you put this whole mess inside of the square root into your calculator, you should have ended up with positive 81. And in our denominator, 2 times 1 is just 2. Now, we know here that 81 is a perfect square. It's just equal to 9. So we're really left with x equals 1 plus or minus 9 over 2. So to get your two different answers, you should have done 1 plus 9 divided by 2 and 1 minus 9 divided by 2. 1 plus 9 is 10. 10 divided by 2 is 5. So your first answer should have been 5. 1 minus 9 is negative 8. Negative 8 divided by 2 is negative 4. So your two answers for this equation should have been 5 and negative 4. Now I want you to think about how you did on this checkpoint question by yourself before watching the answers. If you feel like you were not really able to solve this at all by yourself and you want to start a little more basic, I want you to start in red. If you tried to solve, you were able to get your A, B, and C, but maybe messed up in simplifying your quadratic equation, I'd like you to start with the yellow problems. And if you really understood that, you got the same answers as me and your work matched it as well, you can go ahead and start in green. You'll notice that the problems for this lesson jump around a little bit. They're not necessarily in order, but they all come from page 11 and page 12 in your notes packet. So I want you to pause this video now, take about 10 to 15 minutes to work on these problems. Please go nice and slowly, show all of your work and use a calculator, and then you can come back here to check your answers. Before you move on, I want to just notice that at this point, you know how to do 5 different problems in your regions packet. So no matter which group you're in, red, yellow, or green, you can go ahead and try to work on those 5 regions packet questions. So again, please pause the video. If you're in red, we're going to need to see you doing the red and the yellow problems. If you're in yellow, we want to see you doing yellow and green. And if you're in green, we want to see you doing green and getting up to the extension. Okay, so at this point in the video, you should be coming back here only to check your answers if you've already tried the problems by yourself. Here are the answers to the top of page 11. Here are the answers to the bottom of page 11. Here are the answers to the top of page 12. And here are your answers for the bottom of page 12. Again, if you'd like any further clarification on any of these questions, please come to Extra Help or message any of us to get extra help on these problems. The last thing that you should be doing after you go into Google Classroom and you submit a picture of your checkpoint question and independent practice to get your classwork credit is go onto your exit ticket. By now you should have already done the first 3 problems, so now you're up to the last problem, number 4, which you should be solving by using the quadratic formula. At this point, you're now done with this exit ticket, so that can also be turned in on Google Classroom.